We're going to go ahead and investigate number 71 from section 2.4, which deals with quadratic functions. If you do not already, please make sure that you have the textbook out and open in front of you. Also, please make sure that you have your notebook and something to write with so that you can jot down important pieces of information that we pick up as we read through the problem. If you don't have any of those things at the moment, please go ahead and pause the video and then just restart it once you're all set. So for number 71, we are provided the information that at a time t seconds, after an object is tossed vertically upward, it reaches a height s in feet, given by the equation s is equal to 80 times t minus 16 t squared. So first off, let's identify what those variables mean. So here we have s, and we said that s was the height, and the unit that we will use to measure it is feet. We also have t. T is going to represent time, and the unit that we will use to measure it is seconds. So I strongly suggest that you identify what each variable means and the unit that corresponds to it. Because, for example, if I wasn't paying attention, I might look at s and kind of think, oh, s means seconds. So in this case, I would say on part of the author for this problem, it might have been a poor choice to pick these particular variables to describe each of these units. But I digress. So let's move on. We are also provided the formula s is equal to 80t minus 16t squared. So let's think about this. First off, ask yourself, what's the degree of this polynomial that you've been given? And hopefully you're noticing that the largest degree here is 2. And what do we know about the shape of an equation if its highest degree is 2, and if we were to graph it? And hopefully you're saying, well, it would take on some sort of parabolic shape, or it would take on a parabola, or maybe some people would describe it as a big U. Okay. So if we were to rewrite this, though, and tell me if you believe that I can do this. Is the equation that I have written in the navy color the same as the equation that I have written in the green color? And can you justify why that is? And hopefully what you are saying is, yes, they are the same. I've just rearranged the right-hand side. And the reason why I'm allowed to do that is because of our commutative property of addition. I'm allowed to move terms around. It's very similar to a situation where if I said 3 plus 4 is the same thing as 4 plus 3. Okay, so let's kind of take some notes here. We did note that this would take on a parabolic shape. Notice that your lead coefficient has a negative in front of it. So that means that, in general, your parabola is going to look something like this. It's going to open up downward. Okay, so we have all this information, and I think that's going to help us. So let's dig a little bit deeper into 71. The question that we have is, in how many seconds does the object reach its maximum height? Well, what's the highest point on this little rough sketch of the parabola that I have? So maybe you're looking at what you have written in your notes and you're saying, well, it would be something here, because everything else you're climbing up to that highest point, and then as you move over to the right, you're going down the hill. So in this case, note this is the vertex. And the vertex will also be your maximum point, or in other words, we can describe it as the highest point. Okay. So if we're asked to find out how many seconds does the object take to reach its maximum height, that means that our goal is to find out what t is equal to. Okay. Also notice the relationship that's happening here. Okay, we're used to working with variables like x and y. And there's a cause and effect relationship that we had discussed in class prior. X is going to be the cause, and y will be the effect. Okay, so if we can kind of distill it, take it out of the x and y, and just kind of look at it in general. let's note what our cause is and what our effect is with respect to the variables that we have, in this case, s and t. What do you think would be a cause, and what do you think, which variable would be the effect? Well, I would say if we're trying to follow the path of an object that we've thrown up into the air, I would say that the time would be our cause, because at any point in time, we would be able to locate the height of the object in its path. Okay, so if we were to kind of put these to make them look like ordered pairs, our t is kind of like our x variable and our s is like our y variable. Well, our goal is to find the maximum time, or sorry, the maximum, yeah, we want to find the maximum time. So in this case, let's go ahead and use our little trick. We can say t is equal to negative b over 2a, because again, t is kind of like x. And this is our shortcut that we use in order to calculate the x value, or the cause value in our vertex. So in this case, our b will be positive 80, and our a will be negative 16. So this gives us negative 80 over negative 32. So right away, I can tell you that these negatives, since you have a negative divided by a negative, that'll make it positive. And then 80 over 32, you can reduce that down, and that will become 5 over 2, or 2.5 if you use the decimal representation. And recall that the units that we used are seconds. So our solution is the time that it takes for this object to reach its maximum height is going to be 2.5 seconds after I toss it into the air. So hopefully this explanation worked out pretty well. If you have any additional questions, or if you have any additional suggestions on how I can streamline the explanation, please, by all means, I appreciate the feedback.